While NATO focuses on traditional naval superiority, Russia has been building something completely different in the Arctic, a nuclear-powered fleet that operates where no other navy can even survive. And it's changing everything about global power. Right now, Russia controls the only operational fleet of nuclear-powered icebreakers in the world, not the United States, not China, not any NATO member, only Russia. These aren't just ships breaking ice, they're mobile military platforms, resource extraction enablers, and strategic choke point controllers operating in the planet's most hostile environment. The question isn't whether other nations want this capability. The question is why, after decades of trying, no one else has achieved it. By the end of this video, you'll understand exactly why Russia's Arctic nuclear fleet represents an asymmetric advantage that fundamentally shifts the balance of power in the polar region. You'll discover the technological barriers preventing other nations from replicating this capability, the strategic implications for global trade routes, and why military planners in Washington and Brussels are scrambling to respond. The reality is more complex than most media coverage suggests. Let's start with the basics. What exactly makes Russia's Arctic fleet unique? The Russian nuclear icebreaker fleet consists of 5 operational vessels as of 2025. The flagship, 50-let Pobedy, meaning 50 years of victory, displaces 75,000 tons and generates 75,000 shaft horsepower through 2 nuclear reactors. It can break through ice up to 9 feet thick while maintaining continuous forward progress. For context, that's thicker than the roof of most buildings. But numbers alone don't capture the significance. These vessels operate year-round in conditions that would trap conventional ships for months. Water temperatures hover around -2 degrees Celsius. Ice fields stretch for thousands of miles. Storms generate waves that can flip military destroyers. Yet these icebreakers maintain regular schedules escorting cargo ships, supporting military operations, and establishing Russian presence across the entire Northern Sea route. The Northern Sea route itself runs 5,600 nautical miles from the Kara Sea to the Bering Strait. It's the shortest maritime path between Europe and Asia, potentially cutting transit time by 40% compared to the Suez Canal route. But here's what matters militarily. Russia controls every port, every rescue station, and every navigation checkpoint along this route. Complete domain awareness, complete access control. Before we go deeper into why no one can replicate this, a heartfelt thank you to our channel members and everyone who contributes. Every bit helps us continue creating content and improving daily so you can enjoy even more in-depth analysis. If the strategic implications of Arctic control intrigue you, you'll want to stick around for what's coming next. The technological barriers are far more interesting than most people realize. So why hasn't anyone else built nuclear icebreakers? The United States attempted this exactly once. The NS Savannah, launched in 1959, was a nuclear-powered merchant ship. It operated for 10 years before being decommissioned due to prohibitive costs and regulatory complications. The U.S. Coast Guard's icebreaker fleet relies entirely on conventional diesel-electric propulsion. Their heavy icebreaker, Polar Star, commissioned in 1976, requires constant maintenance and can barely operate beyond a few months per year. China announced plans for nuclear icebreakers in 2018. 7 years later, none are operational. The technical challenges aren't just about building a nuclear reactor. They're about building a nuclear reactor that can withstand sustained ice impacts, generating forces equivalent to repeated car crashes, while maintaining reactor safety parameters in sub-zero conditions with minimal shore support. Infrastructure. Russia's experience comes from 60-plus years of continuous operation. The first nuclear icebreaker, Lenin, launched in 1959. That's the same year the US gave up on nuclear merchant vessels. While other nations abandoned the concept, Soviet engineers refined reactor designs, developed specialized steel alloys that remain flexible at extreme cold, and created operational procedures for maintaining nuclear safety in the Arctic's unique environment. The military implications extend far beyond icebreakers themselves. Russia's Northern Fleet operates strategic ballistic missile submarines from bases on the Kola Peninsula. These submarines can access patrol areas under the Arctic ice cap, where detection by satellite or aircraft is nearly impossible. Sonar conditions under ice create acoustic shadows that make submarine tracking extraordinarily difficult. The icebreakers maintain access to these bases year-round, ensuring continuous deployment capability. Compare this to NATO's situation. The alliance's northernmost major naval base is in Norway. Effective Arctic operations require forward logistics, rescue capabilities, and navigational support. Russia has 13 Arctic military bases operational as of 2025. The United States has a research station at Thule, Greenland, primarily focused on missile warning rather than naval support. This creates what military strategists call area denial. Russian forces can operate freely in Arctic waters, while potential adversaries face massive operational challenges. It's not about ship-to-ship combat. It's about one side being able to sustain presence while the other cannot. Here's where the economic dimension becomes critical. The Arctic contains an estimated 90 billion barrels of oil and 1,680 trillion cubic feet of natural gas. That's roughly 13% of the world's undiscovered oil and 30% of its undiscovered natural gas, according to U.S. Geological Survey estimates. Most of these resources sit in offshore fields that require year-round access for extraction. Russia's nuclear icebreakers enable this access. They escort drilling platforms, supply vessels, and LNG tankers through ice fields that would be impassable otherwise. The Yamal LNG project, operating above the Arctic Circle, exported over 18 million tons of liquefied natural gas in 2023. Every cargo shipment required icebreaker escort. Without the nuclear fleet, this project would be economically unviable. But here's where the story takes an unexpected turn. Russia isn't just maintaining its Arctic advantage, it's expanding it dramatically. In 2024, Russia launched the Rossiya, a new icebreaker design generating 120,000 shaft horsepower. That's 60% more powerful than the previous generation. It can break through ice over 13 feet thick. More importantly, Russia has 5 additional vessels of this class, either under construction or planned. The strategic calculus changes when you move from maintaining current capabilities to expanding them. By 2030, Russia projects having a fleet of at least 9 operational nuclear icebreakers. No other nation will have even one. The gap isn't closing, it's widening. This expansion coincides with accelerating Arctic ice melt due to climate change. Paradoxically, while reduced ice coverage makes some routes more accessible to conventional vessels, it also makes the Northern Sea route viable for longer portions of the year. Russia's nuclear icebreakers ensure they control access during the critical shoulder seasons when ice conditions remain challenging but not impassable. What happens when one nation controls the world's most strategic emerging trade route? The answer involves more than just shipping. Stay with me, the geopolitical implications get even more complex. Let's talk about the submarine dimension that changes everything. Russia's newest ballistic missile submarine, the Bore class, carries 16 Bulava missiles. Each missile can deliver multiple independently targetable nuclear warheads. These submarines operate under the Arctic ice pack, where they're virtually undetectable. The ice provides natural protection against anti-submarine warfare assets. The icebreakers play a dual role here. First, they maintain access to submarine bases, enabling year-round deployment. Second, they can create channels through ice fields, allowing submarines to transit to and from patrol areas while minimizing exposure to detection. This isn't speculation. Russian military doctrine explicitly describes Arctic undersea operations as a strategic priority. For NATO, this creates a persistent problem. Monitoring Russian submarine activity requires forward-deployed sensors, maritime patrol aircraft, and surface vessels. In the Arctic, maintaining these assets faces the same operational challenges we discussed earlier. You can't sustain anti-submarine warfare operations in an environment where your ships can't even operate without icebreaker support. Now we need to examine why other nations can't simply build their own nuclear icebreakers, even with unlimited budgets. The technical barriers start with reactor design. Nuclear reactors for icebreakers must be compact enough to fit within a ship's hull while generating tremendous power. They must operate safely despite constant shock loads from ice impacts. They must be maintainable by small crews in remote locations. And crucially, they must use low-enriched uranium to comply with international non-proliferation standards. Russia's RITM-200 reactor, powering the latest icebreakers, generates 175 megawatts thermal. It operates for 7 years between refuelings. The entire reactor core weighs only 65 tons. Developing a comparable design would require decades of engineering work and billions in research funding. Then you'd need to build the infrastructure to manufacture reactor components, train crews, and establish regulatory frameworks. But there's a deeper issue: institutional knowledge. Russia has operated nuclear icebreakers continuously since 1959. That's 66 years of accumulated experience in Arctic nuclear operations. You can't purchase that knowledge, you can't download it. It exists in operational procedures, in engineering cultures, in the accumulated problem-solving experience of thousands of operators and maintainers. The most fascinating part? The technological advantage is only half the story. The strategic chess game playing out in the Arctic involves dimensions most analysts completely miss. What comes next reveals the real game. Here's the complication that makes everything more urgent: China. China has declared itself a near-Arctic state, despite being located over 1,000 miles from the Arctic Circle. Chinese shipping companies have sent vessels through the Northern Sea route with Russian icebreaker escorts. Chinese companies have invested in Russian Arctic resource projects. This isn't casual commercial activity, it's strategic positioning. For Russia, this creates both opportunity and risk. Chinese investment provides capital for Arctic development, but Chinese presence potentially dilutes Russian control. The balance works only as long as Russia maintains absolute control over the icebreaker fleet and the infrastructure supporting Northern Sea route traffic. For the United States and NATO, Chinese-Russian cooperation in the Arctic represents a worst-case scenario. It combines Russian operational capability with Chinese economic resources and shipbuilding capacity. If China eventually develops its own nuclear icebreaker fleet, a project requiring 15 to 20 years, even with maximum effort, the Arctic could become a zone where Russia and China present a combined challenge to Western interests. Let's address the environmental and regulatory dimensions that complicate any response. Building nuclear-powered vessels faces massive regulatory hurdles in Western democracies. Environmental reviews, public consultation processes, and safety approvals can extend over a decade before construction even begins. Russia's approach involves centralized decision-making and acceptance of risk levels that Western regulatory frameworks wouldn't permit. This isn't a value judgment, it's a practical reality. The US would need to modify or bypass numerous environmental laws to construct nuclear icebreakers on anything approaching Russia's timeline. Public opposition to nuclear-powered civilian vessels remains strong in most Western countries. These political and regulatory barriers matter as much as technical challenges. Meanwhile, the Arctic environment itself is changing rapidly. Summer ice coverage has declined by roughly 13% per decade since satellite records began in 1979. Some projections suggest ice-free summers by 2040. Paradoxically, this makes Russian icebreakers more valuable, not less. Even in reduced ice conditions, shoulder seasons and winter operations require ice-breaking capability. The nation controlling that capability controls access. So, what does all this mean strategically? Russia's nuclear icebreaker fleet represents a unique form of power projection. It's not about force multiplication in traditional terms. It's about enabling presence in an environment where others cannot maintain presence. It's about controlling access to resources and trade routes that become more valuable as traditional routes face challenges. The United States and NATO have begun responding. The US Coast Guard has requested funding for new conventional icebreakers. Finland is constructing a multi-purpose icebreaker. Canada has announced plans to expand its icebreaker fleet. But none of these programs involve nuclear propulsion. None match the scale of Russia's expansion. And most importantly, none will be operational for at least 5 to 8 years. By the time Western icebreaker programs deliver operational vessels, Russia will have further consolidated its position. The technological gap will have widened, the institutional knowledge gap will have grown, and the strategic implications will have become even more entrenched. The Arctic isn't a future battleground, it's a present reality where one nation holds advantages that fundamentally reshape strategic calculations. If this analysis has given you a new perspective on Arctic geopolitics, consider subscribing for more in-depth military and strategic coverage. The global chess game is more complex than headlines suggest, and we break down exactly why. Here's the bottom line that military planners understand but rarely discuss publicly. Russia's Arctic nuclear fleet isn't just a collection of ships. It's an entire strategic system built over 6 decades that no other nation can replicate in less than 20 to 30 years, even with unlimited resources. The icebreakers enable submarine operations, resource extraction, trade route control, and military presence in an environment covering roughly 14 million square kilometers of ocean. The implications extend to global power dynamics. Control of Arctic passages affects Asian-European trade flows worth trillions annually. Access to Arctic resources influences energy markets. Arctic submarine operations affect nuclear deterrence calculations. Russia's unique capability means it operates in this strategic environment essentially unopposed. For other nations, the choice isn't whether to challenge Russian Arctic dominance. The choice is whether to invest the decades and resources required to eventually achieve parity in an environment that will look very different by the time those investments pay off. Most analyses suggest they won't make that investment. The Arctic remains Russia's strategic domain. That's the real story behind Russia's nuclear icebreakers. Not that they're impressive engineering achievements, though they certainly are, but that they represent a form of strategic advantage that emerged from sustained investment in a capability everyone else abandoned. And now, catching up may be functionally impossible.